We have been drawing a lot of geometric shapes, and I bet if I asked you to draw a triangle, you could all draw a triangle easily. But what if I asked you all to draw a triangle with the side lengths 3 centimetres, 4 centimetres and 5 centimetres? Would you all draw the same triangle? Could you all draw a triangle? It's trickier than you think. So if we started off, for example, drawing our 5 centimetre base, so we'll start with the longest side first, and 1, 2, 3, 4, 5 centimetres, and I'm using my grid book. That's pretty easy. There's my 5 centimetre base. So where would I draw my 4 centimetres? I'd have to sort of like put it up here and guess where it's going to meet the 3 centimetres from this side. It's not so easy because the 3 centimetre line could be at any angle and the 4 centimetre line could be at any angle, but they only meet at exactly one point. So how am I going to do this? Well, the answer is with a compass, and this is one of the construction skills that I'd like you to know. So you open your compass up to exactly 4 centimetres, which means that the point needs to be right on the end of the ruler and the pencil needs to be at exactly 4 centimetres. Then you put the point of the compass on one end of your base and you scribe an arc. So that means in this arc of a circle, every point on that compass is exactly 4 centimetres from this end of the circle. So the radius is 4 centimetres of that arc. Then you open your compass up to 3 centimetres. So I'll just make it a little bit less. Check that the point is on 3 and the pencil is on the start of the ruler. And I'll just make sure that's really accurate, and it is pretty good. So put your point of your compass now in the other end of the line, the other end of the base, and you scribe another arc, another part of the circle. Now, every point on that circle is exactly 3 centimetres from that end of the base. So that means the radius of that circle, the small circle, is 3 centimetres and the radius of the larger circle is 4 centimetres. So where the arcs cross is the corner of our triangle. So we simply draw a line from the base up to the corner and from the corner down to the other end of the base. So now we have a triangle which has the lengths 5 centimetres, 4 centimetres and 3 centimetres. And that's a very special triangle. You would all have to draw exactly the same triangle because if you are given 3 side lengths, there is only one possible triangle that you can draw because it's a law of congruency of equal triangles. Side, side, side is that law of congruency, and we might be talking a little bit more about that in the coming weeks. There's another thing I'd like to talk to you about this triangle, and that is that a 3, 4, 5 triangle is a right-angled triangle, and the angle that's formed here between the 3 and the 4 is a right angle, and if you put your protractor on that, you would have a right angle, a 90-degree angle. So this is a right-angled triangle, and we're going to talk a little bit about right-angled triangles. Because I know that's a right-angled triangle, it's now actually quite easy for me to draw a 3, 4, 5 triangle on grid paper. So let's try it using the actual knowledge that we know that a 3, 4, 5 triangle is right-angled. So we're going to start off with the 4, and there's our 4 centimetres. And then because this is grid paper, that is a right angle. So I'm going to draw my 3 centimetres up here. So the height of the triangle is 3 centimetres. And then I can simply join those two edges together, those two corners, and I'll check to see if it's 5. So I'll put my ruler on it, and yes, it is 5. So I've been able to verify that. A 3, 4, 5 triangle is a right-angled triangle, and because it's a right-angled triangle, it has lots of properties. So that's the simplest right-angled triangle, 3, 4, 5. And we're going to work a little bit more with this type of triangle in the next tutorial.